Here we have an equation that's not in our standard graphing form for parabolas. You guys should be pretty familiar with how to convert parabolas into vertex form, which is what we called them when we were quadratics. And that would be complete the square. So think about this parabola that we have. We know it's a parabola because there's only one squared term, x squared, and the unsquared term is the y. This tells us that we are going to solve this equation for y. We're going to have a y equals equation, so this is going to be a vertical parabola. So for completing the square, we basically need to get everything that's squared on the squared terms on one side, and then everything that has nothing to do with that on the other side. So I'm going to move things around, reorganize this equation, and we're going to end up with x squared minus 2x. Then what did we usually want to do here? Plus something equals 20y plus 79 plus something. Now, recall that when we complete the square, we're going to rewrite this side as a perfect square. We're going to write it as x plus or minus something. And to find that, we're going to use negative b, or we're going to use b divided by 2. So we're going to do negative 1. That's going to get us our trinomial all squared, nice and factored form. We're going to square it, and that's what's going to go in the blank. Now remember, from completing the square, we need to add that same value to the other side to keep our equation balanced. So now we have x minus 1 all squared equals 20y plus 80. Now we're trying to solve for y. We want to get our y equals equation. So now let's move the 80 back to the other side. So we're going to end up with x minus 1 squared minus 80 equals 20y. The last thing we need to do to get y all by itself is divide everything by 20. So we're going to end up with y equals. Now think about what our graphing form of parabolas, when we've been looking at them as conics, looks like. It has a fraction. So I'm going to write 1 over 20 times x minus 1 squared minus, let's see, negative 80 divided by 20 is just 4. So now we have this equation in a form that we can use to graph, find the vertex, and find the focus. In fact, I'm going to just look at a couple things while we have it here. The vertex of this one is 1, negative 4. And we can see that we have 1 over 20 is a, so we could say that p equals 5. And then we could go ahead and find the focus, find the directrix, and graph our parabola. So again, we're just using complete the square, something we are already very, very familiar with. So again, we have another parabola, and I know it's a parabola because there's only one squared term and the other variable isn't squared. So our goal is again to get just, in this case, x equals, because x is the value that's not squared. This means this is a horizontal parabola. Here's what's kind of nice. We only have one y term, which means we are not going to have to complete the square. Let's convert it to our graphing form anyways. We want to get x equals, so I'm going to move everything that's not x to the other side. So 3x equals negative y squared minus 6. Divide everything by 3. And again, let's think about how we write our final answer. We get x equals negative 1/3, because we want that fraction there. That's going to help us out. Y squared minus 2. And there we have it in our graphing form. From here we can find the vertex and all sorts of other good stuff. The vertex in this case, h, is negative 2, and y is 0, because we have nothing in there with the y squared term. We didn't have to complete the square. Now if we wanted to find p, this one's a little bit trickier. Remember that 1 over 4p equals negative 1/3. So if we use cross products, we are going to get 3 equals negative 4p. Divide both sides, and we're going to end up with p equals negative 3/4. So our directrix and our focus are going to be at kind of weird numbers, but using this equation, we can still find them. It's okay that they're in a weird place. That's why getting a graphing form is good. That's why we want to get to graphing form. So let's look at a couple others now where we have to complete the square, since that's the trickiest part of this process. First, before you complete the square, you want to identify what variable you're going to do complete the square with. In this case, it looks like we're going to complete the square with y, because that's the squared term. So we want all of the y terms together and everything else away, because that's not going to help us complete the square. So we'll have y squared plus 12y plus something equals negative 6x plus 6, that's a plus sign, I swear, plus something. Now let's complete the square doing b divided by 2. We're going to rewrite the left-hand side as y, and then b divided by 2 plus 6 squared. If we want to rewrite it as y plus 6 squared, we need to make sure we add 36, because 6 squared is 36. Since this is an equation, we want to keep it balanced, so I'm going to add 36 to the other side. Now our equation is going to be y minus 6 all squared equals negative 6x plus 42. Now our goal is just to get this into an x equals form so that we can figure out what the vertex is and we can figure out what the p-value is. So now let's go ahead and move that 42. So we'll have y plus 6 squared minus 42 equals negative 6x. My app was updated and they changed the writing and it makes everything look shorter. Sorry about that. Divide both sides by negative 6. And we will end up with an equation that is x equals negative 1/6 y plus 6 all squared plus 7. It's positive 7 because a negative over a negative is a positive. Now that we have this, we can identify the vertex and we can find p and all of that awesome stuff to find our graph. So in this case, the vertex is going to be hk, which is 7, negative 6. Remember this kind? This is where we have a value that is not 1 as the coefficient on the squared term. It's okay. We're still going to solve it the same, or we're going to convert it the same way we would do any other complete square problem. We're going to keep the x terms together because that's what I'm going to complete the square on. I'm going to move the others to the other side. In this case, I just need to move the y. Now, we need to factor out that 5 before we can do our plus somethings. So when we factor out the 5, we're going to have x times x squared plus 2x plus something, and that is going to equal y plus 7 plus something. Now let's go ahead and find that something. So we're going to rewrite the left-hand side. To rewrite the left-hand side, we'll have to do b divided by 2. And because that's part of our squared term now, we're going to square it. That's 1. But you didn't add 1 to this side. Remember, you added 5 times 1. So on the right-hand side, I'm going to add 5. Now my right-hand side is y plus 12. Our goal is just to get y by itself, so all I have to do in this case is move the 12, and we will end up with a final equation of y equals 5 times x plus 1 squared minus 12. So we can see our vertex, since this is a vertical parabola, our vertex is going to be at -1, -12. And I know you're looking at that 5 going, that's not a fraction. I'm used to seeing fractions there. That's okay. 1 over 4p is the same as 5. And if we want, let's write it as 5 over 1. So we can use our cross products. 1 times 1, 5 times 4p, and so you're going to have 1 equals 20p. So p equals 1/20th, which is perfectly fine. Yes, the focus in the directrix will be at weird numbers. However, we can still find them, and we can still use them to make predictions about this situation. Let's look at just one more to help us practice our completing the square skills. In this case, it looks like x squared is the squared term again. So we're going to have x squared plus 14x, and yay, we don't have to factor anything out, so I'm going to get my plus something ready to go, equals 12y minus 97 plus something. So now let's write the left-hand side as a perfect square trinomial. So we're going to do b divided by 2. In this case, that's going to be 7 squared. Gets me 49. Add 49 to both sides. So our right-hand side is going to become 12y. Now we have negative 97 plus 49, which is perfectly fine, even though they're big numbers. So we have negative 48 because 97 is the negative number. Now we can move everything, and we're going to get y by itself. So I'm going to start with the 48. X plus 7 squared plus 48, because we moved it to the other side. And again, I apologize for this nasty writing. Equals 12y. Divide both sides by 12. And here we're going to write our fraction again. So we'll have y equals 1/12. We want to write it that way so it's really easy to see how we can find p times x plus 7 squared plus 4. So we can see here that our vertex is at negative 7, 4, and we could find p. In this case, it's kind of easy. It's just 3. So completing the square is a way for us to get our equations of parabolas into our graphing form. What's kind of cool is that this same technique is going to be used for all the other conic sections. We're going to be completing the square more and more and more, but the same basic techniques of doing b divided by 2 and squaring it will still hold no matter what conic section we're looking at.